Welcome, infrastructure admins, to this explainer. Let's jump right in. Today we are focusing exactly on the title of this session, NCP-MCI 7.5, 6.5 clone and restore from snapshots/recovery points. Now this is an absolutely critical domain for baseline AOS 7.5 and AHV 11.0. We're going to get into the granular details of how Nutanix handles identities, configurations, and those really tricky edge cases when you perform these operations. Okay, let's dive into this.
To get you completely exam ready, here's our roadmap. First, we'll cover why clone and restore matters. Second, a walkthrough on cloning and customization. Third, we'll walk through restoring previous states. Fourth, we'll hit those exam traps and edge cases. And fifth, the key facts to memorize.
All right, Section 1. Let's look at why cloning and restoring matters.
Okay, let's start by nailing down the fundamental difference between cloning and restoring in a Nutanix environment. A clone is what we call an out-of-place operation. It creates an entirely new, actually think of it as a completely independent entity. Because it's independent, the system generates a brand new universally unique identifier, or UUID, for it. On the flip side, a restore, which you'll also see referred to as a revert, is an in-place operation. It completely overwrites the existing VM, taking it back to a prior point in time, but, and this is key, it deliberately retains the original UUID and MAC address. Honestly, understanding this difference in identity management is the foundation for everything else we're going to discuss today.
Now, because clones create new identities and restores revert them, you really have to understand how Nutanix Gets Tools, or NGT, handles these shifts. So NGT is that software package installed inside the guest operating system, right? And it contains the Nutanix Guest Agent, or NGA. This agent communicates directly with the Nutanix cluster to manage things like VM identity, advanced data protection configs, and self-service restores. Think about it. If you clone a VM and it boots up thinking it's the original VM, you'd have a massive network conflict. Nutanix prevents this, and we'll see exactly how in the next few steps. Moving on to Section 2. Let's walk through cloning and customization.
Picture the Prism Central UI. Let's walk through the exact steps and rules for cloning a recovery point. The standard operational path requires you to first open the application switcher and select the infrastructure application. From the navigation bar, you just go down to Compute and then select VMs. Once you click on your target VM, you navigate over to its Recovery Points tab. From there, you simply select the specific point in time you want, click Actions, and then click Clone. It's a super straightforward path, but the exam isn't going to test you on just clicking buttons. It's going to test you on what happens next.
During that cloning process, you're highly likely going to need to use guest customization. If you just boot up a raw clone, it's going to have the exact same computer name and, critically in Windows environments, the exact same security identifier, or SID, as the source VM. To prevent these conflicts from blowing up your network, Nutanix allows you to inject customization scripts right then and there. You use sysprep for Windows VMs and Cloud Init for Linux VMs. This basically ensures your newly cloned independent VM is actually ready to join the network safely.
Guys, pay close attention here. Massive exam alert. When you are writing custom sysprep scripts directly in the Prism Central UI, you absolutely must use a double backslash for all escape characters. So if you need an escape character like \v, you literally have to type it out as //v. I know it sounds minor, but this is a very specific, highly testable detail that will easily trip you up if you aren't prepared for it.
And here is a golden rule derived straight from the Nutanix documentation. If you clone a VM, by default, NGT is not enabled on the cloned VM. The cluster does this on purpose. Since a clone gets a brand new UUID, if the Nutanix guest agent woke up immediately, it would cause instant identity clashes with the source VM. Because of this, you have to manually enable NGT from the UI. If the clone is powered off, you just enable it and then power it on. But if it's already powered on, you have to enable it in the UI and then manually restart the Nutanix Guest Agent service inside the Guest OS.
Okay, Section 3. Let's switch gears and walk through restoring previous states.
Let's contrast that whole cloning process with an in-place restore, which, remember, the UI refers to as a revert operation. Reverting a VM uses a nearly identical navigation path in Prism Central. You go to Compute, then VMs, select your VM, and hit the Recovery Points tab. But instead of clicking Clone, obviously, you click Revert. Remember the fundamental rule here. This does not create a new entity, it completely overrides the original guest VM with its historical state.
The revert operation is all about retention. Because you are rolling back the existing VM,
your network routing, your MAC addresses, and your UUIDs are all fully retained. The VM keeps its identity. However, there is a crucial catch with the NGT state. While the NGT configuration is restored from the snapshot, the service itself is left disabled. Just like with a clone, Nutanix requires your manual intervention to re-enable the NGT service after a revert. Do not forget that step.
Now, things get a little spicy if your snapshot includes in-guest ISCI attachments to volume groups. First, upon restore, the VM connects to the volume group using the data service's IP address as the target, meaning any previous target IPs are cleared out. Second, volume groups will actually lose their statically configured IP addresses upon restore. And crucially, the ISCI qualified name, or IQN, changes. To prevent conflicts with the active storage, the system appends a Nutanix timestamp directly to the IQN. The format looks exactly like this: :NTNX-timestamp. Thankfully, once the VM boots, the Nutanix guest agent reads the updated config from the NGT CD and updates the guest automatically. It's a lifesaver. All right, Section 4, Exam Traps and Edge Cases. This is where we separate the passing scores from the failing ones.
Let's look straight at the source documentation. There are critical caveats for NGT services and static IP configurations that you really need to heed. First, just reinforcing what we've already learned. A restored or cloned VM does not have the NGT service installed and enabled by default, even if the source snapshot originally had it running perfectly. You have to account for this in your recovery runbooks. But there are also massive traps regarding networking. Let's look at those.
This one is a classic trap. It's all about how IP address management, or IPAM, interacts with restores. If you try to restore a VM from a snapshot that had a static IP configured, but you do not have an IPAM pool configured on that network, the restore operation is going to outright fail. No way around it. If an IP pool is present, the operation succeeds, but the VM pulls a completely new IP address from the pool, completely abandoning its old static IP. To fix this and get that old static IP back onto the restored VM, you actually have to manually remove the network interface card from the old configuration and attach it to the new restored VM.
Another strict exam requirement you got to know involves storage policies. The system does not automatically migrate the storage policies of guest VMs or their disks during a recovery or restore to a new cluster. You are strictly required to manually reassign these storage policies to the guest VMs after their recovery. If you try to jump the gun and perform operations like cloning, decrypting, or re-encrypting before doing this, those operations will fail.
Oh, and be acutely aware of replication schedule constraints regarding the revert operation. You can only manually revert entities that are protected with asynchronous replication schedules. That's it. If a VM is protected by near sync or synchronous replication, the revert operation is strictly unsupported. Mark that one down.
Finally, Section 5. Let's bring it all together with the key facts to memorize.
Burn these golden rules into your brain for exam day. When you perform a clone, you are generating a new, unique UUID and MAC address. You manage the guest OS identity using sysprep, remembering those double / escape characters, or cloud init. When you perform a restore, you retain the original UUID and MAC. But in both scenarios, NGT requires your manual intervention to re-enable the services safely. And remember, for in-guest iSCSI, the Nutanix guest agent is vital because it auto-updates the guest with the new timestamped IQN. Before you go, let's test your attention with a quick pop quiz. Imagine a scenario where a VM has an in-guest iSCSI attachment to a volume group. Do you remember exactly what happens to the IQN when you perform a revert operation? Think about why Nutanix would need to alter it in the first place.
If you answered that the IQN gets a specific recovery timestamp appended to it, formatted exactly as :NN-TNX-timestamp to avoid network storage conflicts, you are well on your way to passing. Keep reviewing these exact architectural behaviors. If you truly understand why Nutanix disables NGT and why it changes IQNs to protect your environment, you will absolutely ace the cloning and restoring objectives on the NCP-MCI 7.5 exam. Thank you for joining me on this explainer. As you continue studying, I want you to ask yourself, how do these exact cloning and restoring behaviors change when we introduce advanced disaster recovery runbooks across multiple availability zones? Something to think about. Until next time, keep exploring.